Like it installed everything by itself. By itself. I didn't have to tell it to. Nice. I had to copy over one file of data, and that was it.
All right. Well, let's go ahead and get started. I have not graded your test, but we will talk about the solutions today. So this way, you know how you did in the test, and then on Thursday you will have your graded exam back. Okay. How was your weekend? How was your long weekend? Really long weekend. It's like a 4-day weekend. Busy? Okay. I was a nomad, I went to different places and, I had meals in mostly other people's houses, so. All right. So before we get started, I just want to kind of point out a few things that I think are kind of interesting. This is a Raspberry Pi. How many people know what is a Raspberry Pi? Okay, very good. I'm impressed. You guys are.
Minecraft on it now. I know. You can get Minecraft on it now.
You can get a lot of different stuff. Anything that you can run in Linux, you can get it on the Raspberry Pi.
Someone made a Lego case
So it's got a USB port.
So the Raspberry Pi is basically a hardware platform that can run Linux.
It's just a little computer. You can put it in an Altoid cam. That's small.
I can show you the block diagram of the Raspberry Pi.
Isn't it running a modified version of Debian or something?
Sorry?
I think it's running a modified version of Debian or something.
Yeah, Debian has a port to the ARM architecture. I'm just going to show you the block diagram here, so I'm not going to talk too much about it because it's not exactly related to algorithms, but it does show you what how things have progressed in the past. When you look at this picture, just looking at the block diagrams, you can see that this is the main processor, which is kind of not interesting. You can also get a 512 megabytes version of the same thing. But if you just look at the output or the ports, you have an HDMI port to hook it up to an HD TV. You have your LAN port to hook up to a wired network interface. You have your USB port, which opens up all sorts of possibilities. You have LEDs, which are useful for indicators, primitive indicators if you don't have a screen or anything else to output to. You have audio ports. You have an RCA video for older, type of equipment. And you have GPIO, which stands for General Purpose I/O. There's no hard drive, on this particular board. You have an SD card slot instead, so you can buy a 32 gig, SD card and use it as quote unquote the hard drive. You can also hook up to an external hard drive, through USB. So there are lots of possibilities there. But I think the system can only start up using the SD card slot and not using the USB port. And that's it. This is the hardware. This picture is also to scale, which means the whole thing is really small. I mean, in terms of the dimensions. It's $35 from this particular vendor, which may or may not be the least expensive one. So for $35, in this case, you can get a 512 megabyte version of what I just talked about. The question is, what am I going to do with something like this? We talked about it in the previous class already, so some of you may have heard it.
Media center.
You can use it as a media center. You can use it as a, in the previous class, I illustrated how you can use it, turn it into a IP camera. Turn it into your own IP camera where you can choose your own camera and install ZoneMinder, to turn it into basically a home surveillance, center. Basically, ZoneMinder turns your Linux board into its own web server. You can log into it, and you can look at all the pictures, and you can automatically strip recording based on motion and amongst other things. What else can you do with something like that?
I think this is one of the really coolest things I've seen because last semester one of my professors was talking about this. And the student had bought one in the class, and he planned to make his own homemade test screen to control like his car.
Okay.
Using that, I thought it was really cool.
May I ask which class would that be?
It was Dan and Naya. He was the professor, and it was
At Folsom?
It was like introductory computer science.
Okay.
But one of the students there, the chief professor or something like that. Yeah.
Is it Dan over at Folsom?
He goes to Consumers River too.
Consumers? Okay.
And he's kind of like
Okay. How about robotics? If you look at the size of this, you can go into a relatively small robot. You don't need anything that's huge. In fact, if you know how to interface this to a Roomba, interface, you can use this, as the brain of a Roomba, and then, and that's an interesting platform all on its own. Okay. Yep. They sell kits to hack, Roombas. So it's just interesting. Basically, for $35, you get the hardware. Just add software and you have your solution.
It's really easy too.
What about support of devices? Do I have to worry about, is it going to support this webcam? Is it going to support this external mass door device? Is it going to support this and that? Anything that I can hook up to my desktop distribution of Linux can be supported by this because it's Linux. Okay, it's just the same device drivers cross-compiled onto a different platform. It's the same software. What can I do with 512 megabytes? I mean, that doesn't seem like a lot. I mean, you guys are buying gaming computers with 16 gigs of RAM these days. So this is half a gig. What can you do with only half a gig of RAM? A lot of stuff. Okay, it depends on the operating system. If you can install Windows onto something like this, I would say not a whole lot. Okay, I think Windows may not even start up with only half a gig of RAM. But Linux does not require that much RAM to begin with. It depends on the application that you're running. If you want to run a full up, database application with a lot of, with a huge database, yes, this would suck. Okay. On the other hand, if you want to run it as a webcam, an IP camera, intelligent IP camera, this is okay. It has enough processing power for that kind of purposes. If you want to run it as a media center, for the most part, it's okay. If you want to do a lot of transcoding, obviously, this is not going to work well.
Run XBMC. It'll run XBMC.
You'll run
really
XBMC.
Sophisticated media server.
Okay.
Really, really good.
It's an open source too.
Yeah. And you can also, nice thing about that project, you can install either on, it has its own distro, or you can just put it onto like Ubuntu or Debian or whatever one.
And you can do all your transcoding on a separate PC and stream it to the media center.
Yep, you have to do it somewhere else because this doesn't have that kind of processing power. But the whole thing is, do you see a processor fan? The processor is on this board. Is there a big old fan, blowing cold air on it? No, there's not even a heat sink. And that's because the processor is very efficient. It's not very powerful, but it can do a lot of processing for the power it is consuming. Okay. It's networkable. Okay, you can either use USB and plug in a Wi-Fi card, but that's going to make it look kind of strange, right? I mean, you have a tiny little computer with a big old Wi-Fi card sticking out of it. How big are these Wi-Fi cards now?
Bigger
About the
than
same
that.
size.
About the same size as the plug itself, right? I mean, it's really tiny these days. I got two of those things. You just plug it in, and the only way you can tell from a distance that you have your Wi-Fi card plugged in is the blue light that's blinking. Otherwise there's nothing really sticking out. You have maybe about a 1/4 inch of stuff sticking out of the port, and that's it. And the power consumption is only 3.5 watts. It can consume up to 700 milliamp at 5 volts, which is 3.5 watts. How much is 3.5 watts? Well, in terms of power consumption, some of the LED flashlights, are already more than 3.5 watts. So, we are not talking about a massive amount of power here. It's not tiny either. It's not like you can power this thing up using AA batteries for too long. But yet, at the same time, it's not too bad. In other words, we are looking at something that can be put into another device. For $35, you can put it into something else, another product that you may be making. It doesn't matter what you're trying to make, but you can use it as a controller, the brain of another thing, for embedded system controlling. And yet it has enough processing power. I can tell you, in the good old days, I have to spend about $12 on a 8-bit processor that has very limited processing power that is embedded. For $35, this is a massive amount of resources compared to the $12 thing that I used to use. Okay, and it's already soldered. Okay, for 35 bucks, sometimes you can get quote unquote a processor board, but it comes in pieces, and now you have to do your own surface mount soldering and stuff like that. I know how to do all that stuff, but when it's fully assembled, hey, it's even better. So, once again, it illustrates, how hardware has progressed a lot, and what you can do with something like this depends on software. What kind of software can you do on something like this? Do you have to write device drivers and all the low-level stuff from the ground up? No, it's Linux-based. So you can put Perl, Python, some of the other interpreters, on the same platform. Then you can just write your Perl scripts, Python scripts, PHP scripts. And those are fairly easy programming languages to deal with. You don't have to understand, how to communicate with the network chips and stuff like that. I mean, it's all supported by the operating system. It's no different from what I'm using on my desktop, really. Except my desktop sucks even more because it doesn't have the have a HDMI interface. This one already has an HDMI interface. So very interesting. You can duct tape this to the back of your PC, and no one can notice it.
Or you get the
especially if you use black duct tape. Yep.
Or get the HD TV, and then you have a computer built into your TV now.
It's a smart TV upgrade.
There you go.
Exactly.
And it's running Linux. Even better.
Which means you can actually watch YouTube on your TV and Hulu for free.
So I think it has all sorts of possibilities. I don't have time to mess around with it. Just yet. I have to grade your homework and stuff. But I think over the winter break, I might get one and just play with it and see what else I can do with it, something like that. All right. So it's just something that I thought some people in this class may be interested in. And now we can move back to the boring stuff, such as your exam 2. All right, so what I'll do is I'm going to do all the questions, step by step, full trace and everything. So this way, we know what the answers are supposed to be. And you don't need anything in front of you to see the questions, because I'm going to repeat the questions here. So the first one, it looks like this. Define sub EQ, which stands for equal. Okay, by ref x, by value y. X gets y, and it returns y, and define sub. Okay. So this is one of those kind of interesting combination of features. Most of the time when we use passing by reference, we don't need to return anything, and most of the time when we return something, we don't need to pass something by reference. In this case, it's doing both. This is actually how C does assignment. Okay, so we'll take a look at this later on. And then we have the second subroutine, define sub main. We have a local variable, print, invoke EQ, y goes to x, y specifies x, and then we have x plus, invoke EQ again, x is going to specify x, 5 specifies y, and then this whole thing specifies y again, and define sub, invoke main. That's the entire program. All right, so this is the code of question number 1. Before we actually trace it, are there any questions about the program itself, the code itself? Any particular aspect of this that you have questions about? Yep.
Were there 2 different forms?
Were there 2 different?
Forms of the test? Like, were those questions the same for everybody?
This is the same.
Oh,
There's only one. Yep.
By reference in the invoke statement, x can into y by reference. Is that could that be considered an expression?
Okay. Well, I think I might understand your question. So, are you referring to this part of the invoke?
Referring to ref of y.
This one here? When you pass by reference, it cannot be a general expression on the left-hand side. it has to be something that has storage. And when you refer to just as a general expression like x plus y or 5, something like that, it's a general expression. It has a value, but it doesn't have a place to store itself. So it has to be something that has storage on the left-hand side. So in this case, y has to be something that has storage. Okay. All right, so let's go ahead and start tracing this program. We'll start a new window. And we go in, before we go any further, make a folder to save the files for today. 2012, 11/27. And I think it's really warm for the end of November. I know it's not related to this discussion. When I look at the date, it's like I'm expecting it to be quite a bit colder, but it's not. So this is exam 2, question 1.
It's below freezing in Florida. Last few days.
If I don't see any frost on my car in the morning, it's not cold. If I see frost on my car, and it takes a long time to thaw it out, then it's cold. All right, so we'll go ahead and trace this algorithm in sheet 2. All right, we do need comments because we have a print statement, but we don't need to get back to comments until much later. So I'm going to scroll past this one and start with line number. The next question is, do we have any global variables? In other words, are there any names used in this program that is not accounted for by local, by ref, and by val?
No. Why?
There's one, it's y. Okay, y is a implied global variable. Now in this class, global variables are always implied, they're never explicit. I never say global y or global anything. Basically anything that has nothing, like local, by val, or by ref, those are all global. Do you guys still remember the evolution of the factorial program? How the very first factorial program that we wrote used global variables, and then we gradually removed global variables and turned everything into local, by ref, or by val. Yep.
So wait, then isn't why isn't a global variable because it's by value, isn't it?
It's not by value from the context of main. Remember, by val, by ref, and local, they have a local scope, which means they are only meaningful within the subroutine that contains their definition.
Right. And then, but y is in the subroutine equal.
But not the y on line 9. This y here on line 9 is not accounted for by any of the declarations that we can see, because it's on the left-hand side.
Right.
So it is used. This is something that has to be defined by the time we get to line 9, and we're using it to specify parameter x of EQ. So it cannot be the by val y of EQ because we're not there yet. We are trying to invoke EQ at this point. So it has to be something that's either defined within main itself or a global. But since main does not have any definition of the name y, it has to be global. Okay. Are there any questions about why y is a global? Now that we know y is a global, it's everything else is fairly easy to do. So on line 11, we have to invoke main. First thing we have to do is to say return line number. In this case, I can use return line number because main does not return a value. So return line number is post because there's nothing after line 11. So that's kind of the easy one. And then we have to allocate one column for x because x is a local variable in the subroutine that we are invoking. X as a local variable starts with an unknown value. So that's all we have to set up for invoking main. Once we get into main, we start execution on line 9. Line 9 really has quite a few things to do. In fact, there are, I would say 3 things or 4 things depending on how you look at it. The first thing we have to do is which part?
Innermost.
We start with the innermost of the parentheses, which is an invoke statement, right? So I'm going to highlight here which part we have to deal with first. So the first thing we have to deal with before we can do anything else is to handle this particular invoke of EQ. Does that make sense? Because until we get this part done, I cannot get the other EQ to invoke. Because we require the return value of this invoke in order to supply the value for the addition next to it, and then that in return supplies information or the initial value of parameter y for the other invoke of EQ. Is that okay so far? Okay. So since we're handling this particular invoke, so if I display it side by side, we need something to store information about what do we do after this. Should I use return line number or should I use return info? Return info, because we have to get back onto the same line to finish up some other things that we have to do on that line. So when we are done with this invocation, we are getting back onto line 9. The print is not done yet. The other invoke is also not done yet. So we have invoke EQ, y specifies x, and then we have x plus, and then the question mark, and then this part, will specify parameter y for the other invoke. And this is what it is supposed to be in the return info set. In other words, only the invoke that we're dealing with right now is replaced by a single question mark. The rest of line 9 is really just copied and pasted. Is that okay? All right. And then we also have to remember to specify all the other columns that we need in order to invoke EQ, which means we have to specify what is x and also what is y. Okay, so let's go back to here. Y is easy. Y is a pass by value parameter, and in this case we have a constant of 5 to specify y. X, on the other hand, is passed by reference. Remember, the left-hand side is referring to something in the current context. In other words, from the perspective of main in this case. Main has a local variable x. I'm using local variable x of main to pass by reference to parameter x to EQ. So that means in the trace, local variable x has has column E. So this new column that we're allocating, which is column G, is also known as column E. Are we doing okay so far with this setup? Okay. So once we have the 3 columns set up for EQ, the first EQ, we can continue on to line 4, which is the first line that does anything useful in the subroutine EQ. All it does is to evaluate the value of y and then put that value into x. Y is passed by value. It has a value of 5. X is passed by reference. It is referring to column E. So when we update, we have to update column E to the value of y, which is 5. So that's the net effect of line 4, which is just changing a column to a particular value. Then we get to line 5. Now, line 5 looks very simple, but it's not, it's not that simple. We have to return y. Y has a value of 5, so that means we have to go to the rightmost return info cell, copy and paste it, change the question mark to the value that we are actually returning, which is 5. And that's the end of line 5. After line 5, we get to line 6. Line 6 is the end of the entire subroutine. So that means we have to remember where to go back to and then deallocate the columns. The return info cell tells us that we have to go back onto line 9. So we'll go back to line 9, and then line 9 looks like this. And after this, we have no use of these columns anymore. They will be deallocated. And now we're back onto line 9. Now, when we get back onto line 9 doesn't look like the original line 9. It now looks more like this. So that means we have to invoke EQ again, because before we can do the print. When we invoke EQ the second time, I'm using the global variable y to specify parameter x, and I'm using the sum of x and 5 to specify parameter y. So this time, let's see what we have to do here. Once again, we have to allocate a column for return info. We have to allocate 1 column for x, 1 column for y. Return info tells us that we have to go back onto line 9 because I have to print the actual return value of the second invoke of EQ. We have to specify parameter x. Parameter x is, I use global variable y to specify parameter x. Global variable y is in column C, so parameter x, which is passed by reference, is this time it is referring to column C. And y is specified by x plus 5. X, it has a value of 5, and 5 plus 5 is 10. So y will have a value of 10 in this case. Are there any questions about this part? Why parameter y has a value of 10? Because that's a tricky part. It's kind of tricky in a way because x started off with a value of question mark, and yet by this time it has an actual value. So there's no problem whatsoever with the execution of this pseudocode, even though it seems like I'm using a variable that is uninitialized, but by the time I make use of it, it is already initialized because of the ordering of the invoking of the subroutine EQ. Okay. So now that we can specify all this stuff, we go into the subroutine onto line 4. Yep, go ahead.
So I have a question about the global variable y.
Mm-hmm.
I'm trying to, I don't remember any examples. I'm not saying you didn't show it, I just don't remember where you had a global variable created in that case. So you usually had it defined like outside of a function call, or outside of a subroutine.
I think one of the factorial, some of the factorial examples,
Okay.
yep, some of the factorial programs refer to a name that is not a biref, bival, or local to the subroutine factorial itself, and that implies it is a global variable. I think R as a global variable is implied that way in a few versions of the factorial program. So we're now back onto line 4. Line 4 once again just copies the value of y to x. Y is passed by value. It has a value of 10. We want to store the value of 10 to x. But x is really just an alias of column C. So when we store the value, we're actually storing the value to column C in this case. So 10 is going to be stuck here. And then we move on to line 5 to specify the return value. We are returning the value, we are returning y, which has a value of 10. So we copy and paste return info, and then specify 10, here in the question mark. And now we're getting back onto line 6. Line 6 has 2 jobs to do. One is to figure out where we're going back to. We're going back to line 9. And then the second thing it has to do is to deallocate the columns. So we just use the strike out to represent that. Now we're back onto line 9. Line 9 now looks like this. So we don't have anything else to do before we can print the value of 10. So the output of the program is 10. And after that, we get to line 10. Line 10 is the end of the main subroutine. There's nothing really important to do except to remember where we are supposed to go back to. Return line number tells us that we have to go to post. And then the second thing we have to do is to deallocate the columns that we allocated earlier for main. And we are done with the trace. So based on this trace, I can now start to answer the questions in the question itself. I'm just going to repeat everything here, so you don't need to look at the test to know the answer. Okay. So the first question is there any problem? Blah blah blah. And the answer is no. There are no problems. Okay. Now I know most of you most of you answered this question. We'll talk about that next. So don't worry about it until it is time to worry about it. Okay, so the second question is, what is the issue? And I also know how most of you answered the question here, but the correct answer is not applicable because there's no problem. So the branch to go to line 2 should not happen with this question. Now we move on to question number 3. Trace the algorithm, then answer the following questions. Yep.
What if just put nothing for what is the issue?
If you answer, is there any problem? You answer no, and
What if you just don't put anything?
Yeah,
Like after saying no, like just don't put anything.
You won't get any points deducted. It's not multiple choice. If it's multiple choice, then you get points deducted if you choose the wrong choice. But since this is not exactly multiple choice, you won't get the deduction. All right. So the third question is to trace the algorithm, which you don't have to turn in. The fourth question is not counting the columns for comments, line number, and global variables. What is the maximum number of columns in use at the same time during the execution of this algorithm? Now, we talked about this type of question in the practice test. In this case, we are not counting the columns up to column C because this is comments, line number, and the global variable. So we're only counting columns D, E, F, G, H. So there are 5 columns in this case. So the answer to that question is up to 5 columns are in use at the same time, not counting which is basically the comments, line number, and global variable. The next question is, if the algorithm prints some output, what does it print? And you say it prints 10, okay? Just 10 is fine, Number 6, right after line 9 executes, but before line 10 executes. In other words, we are looking at the transition between this line and this line here. But it has to be before line 10 executes, because by the time line 10 executes, X will disappear. So it doesn't matter, it doesn't make any sense to ask you what is the value of X. So it has to be right after line 9 executes and before line 10 starts. So in that case, X, which is a local variable, has a value of 5. Y as a global variable has a value of 10 right at that moment. Question number 7 asks, are there any global variables or global variables? If so, what is it? What are they? And use a comma-separated list of global variable. So in this case, Y is the only global variable. There's only one. And 8 is you're done with this question, so there's no answer to be expected. Okay. So I know how most of you answer this question, because most of you think there's a problem because Y is, we don't know how to do with line 9 because there's no Y on line 9. I have not decided yet how to grade that, so I'm going to pick all the right answers and grade those first, and then I'll kind of think about what to do with the incorrect answers. Yep.
For me, personally, it's already
Extra credit.
with the storage. What I did was the expression and the random column, the one that was mentioned in the notes, where you write the expression first, then random column, expression comes into storage space.
There's only one correct answer. Y is a global variable. There's really no alternative way of doing it.
I was thinking, since most people, for the people who put it that way, the
Mhm.
answer is given half credit, since
Well, technically it's still incorrect, so I have to decide what to do with it. The suggestion of turning this into extra credit question is okay, which means people who answer it wrong was to get the 0, but since it's extra credit, you only need 3 questions out of 4 to get full credit for the entire exam. So that's a viable answer, but I really do not want to give points to people who answer it wrong because it is actually the incorrect answer. Okay. And I cannot assign points based on voting or popularity either. I cannot assign points because but most of the class answer it this way. It has to be an answer that has points. So I cannot do that either.
But it looks quite easily like when it refers to Y, it only refers to pretty much Y when it's talking about invoking subroutine EQ, which does have a value of 1.
Yeah, but because it's on the left-hand side of the arrow, it is referring to something that we know already by the time we get to line 9.
But it's a double arrow. It could be either way.
Nope, it's not. Because even with a double arrow, even in the case of a double arrow, this specifies the parameter, and this specifies what are we going to use to specify for that parameter. It is still following that convention. So it's still, you cannot, it's not interchangeable. It's not something that you can just reverse the order. One is a parameter, one is what you use to specify the parameter. And if it were, ambiguous, where you can swap it, then we have an issue if we actually have a local variable y. I mean, that will make it just very confusing. All right, so that's that for question number 2. Let's get started with question number 3.
Question number, no, that was question 1.
Oh, that's question number 1. Never mind. Count wrong. Okay, now it's.
Now I doubt if there was a global variable.
Well,
you can count it right.
Well, this is also the behavior. When you write this code in Perl, that's exactly how it's going to be done. Because when Perl encounters a name that is not previously declared, it will just define and say, oh, here's another global variable, and PHP will do the same thing. So this is a convention that's not only used in this class because Taki is a weird guy. It's actually something that is established with most scripting languages, including VB2. Visual Basic will do exactly the same thing. And that is also why, okay, this is also a good time to kind of preach about this. This is also why in most scripting languages like PHP, not PHP, but with Perl and Visual Basic, you can turn that feature off and basically say everything has to be declared. If I use something that is not declared as a parameter or local variable or anything, give me an error message and tell me that something is fishy here. Instead of automatically creating a global variable and saying, hey, it's fine now, don't do that. And it's a recommended procedure too. When you go work for most programming shops, they will require that you turn on those strict settings in the scripting language, just so that we don't run into problems, like what we just ran into. Creating global variables on the fly, without any declaration can be very dangerous. All right, so here's question number 2. Question number 2 has define sub s1 by ref x by ref y by val z. I like this one too. Z sub I gets 3. All right, so this way. Okay, this is the second question. And this one, I did not really intend it to be very tricky. It really just boils down to, can you follow the mechanisms one by one? Just that. But we'll take a look at the trace. Since I'm not printing anything, I don't need comments at all. So I just start with line number. Do we have any global variables in this case? Let's try to do the same analysis here and make sure that we know that whether there are any global variables. So we look at each line and then we analyze, is I a global variable? Can I be a global variable in this case?
No.
No, because there's a previous local declaration, so I has to be a local variable. You look at the next line, which is line 11. Are there any names here that is not defined any earlier?
No, because they're all on the left side.
They're all on the left-hand side. Very good. So they're all referring to the I that we already know at this point, which is our local variable I. Then we move on to subroutine S1. Can X or Z be a global variable in this case?
No.
No, because one is a by ref and one is a by val. They are both parameters. The same thing applies to line 6. Y and Z are both accounted for by the declaration. Y is a biref and Z is a bival. So in this case, the entire program does not contain any name that is undeclared. Okay? We have declaration for every single name by the time we use those names. So the answer is there are no global variables. Yep.
So global variable can be identified when it's not accounted for in the main subroutine.
When a name, by the time you use a name to refer to its value, if it is not declared as local, bival, or biref, then it has to be a global. Yep.
So let's say I was invoking a subroutine within a subroutine, and I didn't declare the value in the main, but I declared in that first subroutine I'm invoking. Then it's still a local variable, not global.
When you said you're invoking something from a subroutine,
Inside another subroutine,
right?
If the value appears in that first subroutine,
You mean main?
No, outside of main, inside the first
Okay.
subroutine that's getting called.
Main
then
cannot
it's-
refer. See, now main cannot refer to any local variable in a subroutine that it is invoking. It can only in this class it can only refer to the parameters that the subroutine is invoking, because you
Right.
have to specify how are you going to specify each and every parameter of the subroutine that you're invoking.
Right. No, what I'm saying is like if there's main and then sub 1 and then sub 2.
Okay.
So if there's a variable being called from sub 2 being called from sub 1 into sub 2 by reference or by value, then that would, and it was declared inside subroutine 1, that would still be a local variable. So it's not being.
Okay, I have to see the code to answer that question. Yep. All right, so in this particular case, we are on line 13 right now. Line 13 has only one thing to do. It has to invoke main. Since main is not returning any value, we're going to specify post as return line number. And main also has a local variable I, so I have to allocate column C for that purpose. All right. Now that we have set up all the columns, we can go into the main subroutine starting on line 10. Line 10 says I should start with a value of 3. Line 11 is going to invoke the subroutine that is really the core of the question. When we invoke that subroutine, we first have to ask ourselves, should we use return line number or should we use return info? In this case, since S1 does not return a value, we can use return line number. So we just allocate a column for return line number that refers to the line that we have to execute after the invocation. The invocation is on line 11. There's nothing, mysterious here. When we come back, we have to go to line 12. And then we have 3 parameters when we invoke S1. We have parameter X passed by reference, parameter Y passed by reference, and then parameter Z passed by value. Let's deal with the one that is passed by value. The one that is passed by value has its value specified by I. But this is from the perspective of main, which means when we refer to I, we are referring to column C, which has a value of 3. So Z, in this case, has a value of 3 to begin with. X and Y are both passed by reference, and we are using I, local variable I, to specify parameter X and parameter Y. So X becomes an alias of the column that contains variable I in main, which is column C, and Y is exactly the same thing. Yep.
So I wrote my trace out. It was okay to just put AKA column C on both X
Yes.
and Y, just all in one line.
Sorry?
I didn't write it twice, basically. I just wrote it as one.
You should write it twice because each parameter has its own
Yeah.
column. Go ahead.
What would be so wrong with just, instead of just saying AKA column C, just writing the value of X, Y, just writing the actual value? You know what I mean? All columns.
Say again?
So I mean, like,
Mhm.
it says AKA column C, just write 3 for X, 3 for Y, and just trace it like on that.
Because when we overwrite X, we are not overwriting column E. When we overwrite Y, we are not overwriting column F. In both cases, when we overwrite X or Y, we're overwriting column C. So this is using exactly the same mechanism that we talked about in the class. When we pass something by reference, you're only giving the subroutine a way to find the original item, and you don't change the parameter itself. Yep.
2 questions. One, would AKA and refer be the same?
Yeah, you can use refer. Since I don't require the trace, you can use any word or phrase you
I understand
want
for
to
my
use.
purposes. I'm saying
Right.
if I were to trace something for your purposes, would refer count as well, or do you
Yeah,
want to see the AKA?
you can use refer to. Yep.
Second question, for when we initialize the defined sub main, that would initialize the return line post. Local I is on line 9. Would that be taken care of right away, or could it be that like when I did my trace, I did line 13 return line number and post, and then I went to line 9, which initialized I at that point instead of at the same time as
For this class, I just combine both into one. So when you invoke a subroutine,
would it be different?
it would still would not change the outcome of the program. In other words, in order to answer the questions. Yeah, when you okay, technically you are correct. Okay, there are actually separate steps. The local variables are actually allocated inside, quote unquote, the subroutine. But in this class, I don't make that separation. You are now well prepared for cisp300. So it's very positive that you're thinking about it. Is it one step, or should I break it up into 2 steps? So the answer is yes. Technically, you are correct. There are 2 different steps, and the local variable I is allocated after as a second step. But in this class, I just combine the steps all together into one. So when we invoke a subroutine, everything that we need for that subroutine is allocated at the same time.
I'm just checking because I know that for like this time you didn't want to collect these, but if you did, I'm trying to make sure that
I will count yours as correct as well. Okay. Any other questions? Very good questions. Yep, go ahead. I don't have a worksheet anymore because it's past the last day to drop the class. So not only can you not drop yourself from the class, I cannot drop you from the class either. Yay! Okay, so on Thursday, I can expect like 1/3 of the class, not being here. It's like, oops. Everybody just goes, oh, okay, just take this class online. And you have to kind of count on tech remembering to turn on the recorder, right?
Just bring our Raspberry Pis and play with the slides.
Or in place of you being here, you will just put your Raspberry Pi here to do the recording, right? and I can use a 4G connection to stream it back to you like live.
Strap it to a Lego.
Yep.
Well, see, you already guaranteed that a lot of people will still be here Thursday because you're heading back to Texas.
Ah, very good.
It's next Tuesday where you can expect basically no one.
Except with little stand, little Raspberry Pis on each place.
Yeah, but who are you going to trust?
All right, so let's go back to this trace here. We are all set up to invoke S1. So now we can continue execution in S1, now starting on line 5. Okay, line 5, by itself, doesn't seem very harmful. The right-hand side is easy to evaluate. The right-hand side of the assignment says we want to compute x plus 2 times z. And surprisingly, I did not have anyone to ask me, should I do the add first or the multiplication first? What is the answer? If someone were to ask me, multiplication first by default. Yeah. Did anyone do the addition first? I hope not. I really hope not, because that's a convention that most people understand by this point, especially in a programming class. If this were a different kind of class, I can see some people may ask that question. Okay, so multiplication has to be done first by convention because multiplication has priority over addition. So we want to compute 2 times z, which is easy. Z is a pass-by value parameter. It has a value of 3. 2 times 3 is 6. Okay. Then we have to add it to the value of x. X by itself has no value because it's an alias of somebody else. It's an alias of column C, which also has a value of 3 at this point. So we have 3 plus 2 times 3, which comes to a total of 9. question is, what do we do with that 9? Well, we have to store it to x. X is an alias of column C, so column C is the one that gets updated to a value of 9. Now, this is very important because we are making use of column C again on the next line, okay? Because on the very next line, which is line 6, we want to compute, x. We want to compute y minus z. Y is also known as column C, and column C now has a value of 9. Okay, so we are talking about 9 minus 3 on the right-hand side of line 6. 9 minus 3 has a value of 6, and what do we do with 6? We store that to y. Y is also known as column C, so on line 6, it is also updating column C now to a value of 6. There's no problem with this type of program. It is called multiple aliasing, which is exactly as the name implies. You just have multiple ways of referring to exactly the same column. Okay? And there's nothing wrong with it. I mean, this program executes the way it is supposed to be, exactly like this.
Is there ever a purpose for multi-aliasing? Because while I got that and understood that,
Right.
I didn't understand the point of having x and y as different things.
Okay, look at it this way. If I didn't do the 2 times z instead it's just z on line 5, it's kind of like transferring funds from one account to another account with online banking, right? So you can specify I want to transfer money from my checking account to my savings account, but there's nothing wrong with saying I want to transfer money from my savings account to my savings account. In other words, you're taking money out of one account and you're putting the same amount of money back into the same account. It may not be intended to deal with transferring money from one account to itself, but there's nothing wrong with doing that either. So by choosing my parameters, I can end up with 2 parameters referring to the same column, but there's nothing wrong. It's by the mechanism itself. In other words, normally you may specify different columns to the different pass by reference parameters, but there's nothing wrong with using the same column to specify those particular by reference parameters either. Yep, go ahead.
I have a question. What would happen if it got really messy and for line 5, Z was also by reference value?
If Z is also passed by reference, then then column C would end up with 0 because on line 6, Y and Z will be pointing to the same column.
Well,
so you'll be
understand that,
subtracting
but
itself.
for line 5 itself, wouldn't it be 2 times Z, so you...
Well, line 5 will end up with the same value. It will still be the same value because you're talking about X and Z referring to the same column, right?
Yes, but then you go 2 times Z, 3 times 2 is 6.
Yeah.
And then because it's referring to the same column, wouldn't it be...
But the assignment, but the changing of that column does not happen until you complete the entire operation on the right-hand side.
That was my question, thank you.
Yep. Because remember, when we talked about assignment statements, you have to perform the right-hand side first to get to a single value, and then you store that value to the left-hand side.
So even though the 2 times Z, if say it was by reference, if 2 times Z does change the value of it, it doesn't change what's...
It doesn't change
referring to
until the entire expression is evaluated.
Okay, that was my question.
Yep, very good.
But
That's a good
for
question.
Functional, it's just going to change instead of having an output of 6, it would just be 0. It's minusing itself.
Well, I understand what would happen on line 6. My question is what would happen on line 5? Would it go from... Because if it was going the way I first thought it was, you'd end up with a value of 12.
No, it would still end up with a value of 9 because the assignment does not occur until the entire right-hand side is evaluated. Yep. But that's a good question. Okay. Now that we are done with line 6, the rest are really just bookkeeping stuff and should not affect the answer of the test at all. Because we get to line 7, it's just reminding us that we have to continue on to line 12, deallocate the columns to be allocated for this invocation. we get on to line 12. Line 12 is the end of the subroutine 2. It reminds us that we have to go to post and deallocate both of those columns to be allocated for that invocation. So go to here, and you just drag it through, and that's the end of the entire trace. And that's why I did not require you to turn in the trace, because you can get to the answers sometimes before you complete the entire trace. In other words, in this case, everything from row 10 of the trace down to row 12 they're all just bookkeeping. Does not change the answer to question number 2 at all. Okay, so to answer the questions, the first question is there any problem? The answer is no. So that will skip question number 2, because it tells you if the answer is no, skip to question number 3. Trace the algorithm and then answer the following questions. Question number 4 asks, not counting the columns for comments, line number, and global variables, what is the maximum number of columns in use at the same time during the execution of the algorithm? In this case, it's 6 columns, right? Because we have columns B, C, D, E, F, G. So the question is 6. Okay, so 6 columns are in use up to. Up to 6 columns are in use at the same time, not counting da-da-da. Okay. And this part, now this kind of thing is good because, even if someone did not pass the parameters correctly, it should still add up to 6 columns. Okay. If someone mistakenly used passing by value instead of passing by reference and stuff like that, it would change the outcome for the later questions. But as far as the counting of the columns is concerned, it will still add up to the same number. So in this case, up to 6 columns. The next question asks, right after line 11 executes, but before line 12 executes, state the values in the following variable, which is I. So I would say I equals to, okay, let's see, this is right after line 12. So this is line 12 here. Right before it executes, I has a value of 6. So I equals 6 right before line 12. Are there any global variables or global variables? There are no global variables. And that's it. That's all the answers to the question. All right, so that's that for this question. Moving on to the third one. Third question. The third question is something that we have seen in class already, just not in this particular type of combination. Okay, so let me just copy the algorithm here first. Define sub S2, by ref x gets x plus 2, return x, and define sub, and define sub main, local I gets 2, print, invoke S2, I specifies x, plus invoke S2, I specifies x, and define sub, invoke main. Here we go. Now this one, I can say the only part that is really tricky is I did not ask for the trace. I think if I asked for the trace, some people would not have made mistakes with this one. I haven't really looked at all the answers yet, but I'll bet you that somebody made the mistake that I'm thinking about. I'll tell you what it is. Okay, now since I did not ask for a trace, so it really is, some people can look at this and say, oh, it's invoking S2 twice, and in each case it's using the same parameters, which is using I to specify parameter x. So some people may think, okay, if I figure out what it is returning in the first invocation, it has to be the same value for the second invocation, add those two together, and that has to be the value that is printing. That would be incorrect. Okay, for this one, it is actually, you have to trace both invocations because it is using something that is changed. Okay, in the first invocation, it would change local variable I. So by the time it is invoking the second time, I starts with a different value already. And the return value of S2 depends on the initial value of the parameter. Yep.
Does it matter if we did the left side or the right side first?
That it does not depend because addition is commutative. So changing the order of the operation does not change the outcome. So I also intentionally make this way. If I had made this a negative or subtraction, then it would affect because whether you evaluate the right-hand side first or the left-hand side first would change the outcome. Multiplication and addition would not have any effect because it is commutative. Yep.
Say it was division or subtraction. Which one should you do first? I know right now it doesn't matter which one should be done first.
Okay, that depends on the programming language that you're defining. In our class, I just say that in most cases, just follow it from left to right. So I would do it, I would perform the left-hand side first and then the right-hand side. But that only applies to this class. When you're programming in C, when you encounter something similar to this, you have to look up the definition of the C programming language or C++ and see how it is defined. I believe in this case it is undefined. Now, how can this be undefined? I mean, how can we not know the order? Well, when we say it is undefined by the definition of the programming language, it simply means there's no specification. It is not required to be done in a certain way. So some compilers will evaluate the right-hand side first. Some compilers can choose to evaluate the left-hand side first, and you cannot say either one is incorrect. Okay. Now, if you have another programming language, I don't know which one, that specifies, in the case of any type of general operator, it has to evaluate from left to right, then the order has to be from left to right. So that means that's what I meant when I said it depends on the programming language and depends on whether it is a part of the specification of the language. Some does and some do not. So if you have a programming language that does not specify the order, then you have to avoid using something like this, because the outcome depends on the compiler. In other words, if you use GCC, it can give you one outcome. When you use the Microsoft compiler, it can give you a different outcome. And that would be bad because that means the source code is no longer compiler independent. Okay. That's a very good question. All right, so let's go ahead and trace this in base by another window. But in this particular case, it does not depend on the order because the operator I choose is commutative. All right. In this case, we do have a print, but we don't have to deal with that until much later. So I'm just going to scroll it out of the way. We have line number. The next question is, do we have any global variables? Okay. On line 8, I is accounted for by local I. On line 9, I is also accounted for in both cases by local I. When we get into the subroutine, on line 3, we have X, but X is accounted for by the byref parameter. So we don't have any names that is not accounted for by local, byref, or byval, so there are no global variables. If there are no global variables, the precondition is really simple to specify because there's nothing to specify. On line 11, we are invoking main. And to do that, we need a return line number. Because main does not return a value, return line number is the easiest way to do it. But it does have a local variable I, which starts with an unknown value. Then we get on to line 8, which is inside main. It says I gets a value of 2, so we are changing I to a value of 2 on line 8. And then on line 9, we have to figure out what to do because there are 1, 2, 3, 4. There are 4 things to do. Technically, there are 4 because we have to evaluate each invoke and then do the add and then do the print. So invoking the left is 1. Invoking the right is the second, the addition is the third, and then printing is the fourth, in that particular order. Okay? But in this case, whether you do the left-hand side first or the right-hand side first is not important. So in this case, let's just say that I deal with the left-hand side first. If I deal with the left-hand side first, either case I still need to return info because I'm going back to line 9 to finish up some other matter. Now I'm dealing with the left-hand side first, which also means the right-hand side has to be spelled out exactly the same way as before, because I'm not taking care of the right-hand side at the same time. In other words, it is not okay to do it like this. It should not be like that. Okay. Now I did not require you to turn in the trace, so I cannot tell how many people understood the question incorrectly and say that, oh, it's just question mark plus question mark. When I have a return, I'll change both question marks to the same value. We cannot do it that way. That's not how the program is going to execute. Are there any questions about this? No questions? Did I emphasize in the class that there should be only one and only one question mark in the return info? I think I repeated that quite a few times. So that's basically what it is. So you can only handle one invocation at a time. So in this case, you can either handle the left-hand side or the right-hand side first, but not both at the same time. All right, so there we go. We are now ready, well, almost ready, because subroutine S2 also requires one additional column, which is passed by reference X. So X is passed by reference. It is now also known as some column. I'm using I of main to specify parameter X of S2. I inside main is local I, which is column D. So X becomes an alias of column D. That. Now we are ready to go into the subroutine S2, starting on line 3. Line 3 says I want to evaluate X plus 2 first. X by itself actually has no value. It refers to another column. But column D has a value of 2. So it is 2 plus 2, which is 4. We store 4 back into X, which is referring to column D. So column D is the one that is now updated to a value of 4. Then we move on to line 4. Line 4 is a return statement. We take the rightmost return info cell, copy and paste it, change the question mark over here to the value that we are returning, which is 4. And we are done with line 4. We are now up to line 5. Line 5 has 2 things to do. One is to look up the return info cell. We have to go back to line 9 after this, and then we can deallocate both of these columns. Now we're back on the line 9. But line 9 only has one invoke to deal with now, because the other one, one is already dealt with. It is now resolved to a single value. We only have the right-hand side to deal with at this point. So once again, we have to reallocate a column for return info. When this is done, we still have to go back to line 9 to finish up the addition and the printing. But this time, parameter X is still the same thing, right? Because I'm still using variable I, local variable I, to specify parameter X. So it is still also known as column D. When we get into the subroutine, we go to line 3 first. Line 3 says, we want to evaluate X plus 2. X is also known as column D. You look up column D, it is no longer 2, it is now 4. Because the previous invocation of S2 changed the value of that column. So now it becomes 4 plus 2, which is 6. We store 6 back into X. X is also referring to column D. So now column D is updated to a value of 6. Are we doing okay so far with this? Okay. Then we move on to line 4. Line 4 is returning the value of X. So we take the rightmost return info cell, copy and paste it, change the question mark, whatever it is, to 6, which is the value that we are returning. And we're done with line 4. We get back onto line 5. Line 5 has 2 things to do. One is to remind ourselves that we have to go back to line 9. And the second thing is to deallocate the columns that we allocated for this invocation. And now we're back onto line 9. But line 9 is now fully resolved. All the invocations of line 9 are now resolved to specific values. It is 4 plus 6, which is 10. So that means this time when we get back onto line 9, we're printing a value of 10. And then after line 9, we proceed to line 10. It's just bookkeeping at this point. We remind ourselves that we have to continue with post. And we have no use of columns C and D anymore. We allocate both of those. Oh, okay. And now we're done. Okay. So to answer the questions in the test, the first question is there any problem? So there's no problem with the algorithm. And then we skip to question, question number 3, trace the algorithm, going to line 4. How many columns, up to how many columns are in use at the same time, not counting the comments, line number, and global variables. In this case, it is columns C, D, E, and F. So there are 4 columns in use during that time. So we say up to 4 columns are in use at the same time, not counting the ones that we are not supposed to count. If the algorithm prints something, this is question number 5, what does it print? It prints a value of 10. And then it asks, right after line 9 executes, but before line 10 executes, state the value in the following variable. Okay, so I equals to, in this case, right before line 10, so we are talking about, up to here, it has a value of 6 at this point. So I equals 6 right before line 10 executes. Yep.
For the test itself, when it asks, is there a problem with the algorithm? If you said no, is that good enough? Or if you left it blank and just skipped, or do you have to write out all these things? Or like,
if you just say no,
if you say,
okay, I'll put it this way. If you answer, questions 4 and below, I can take that as an implication that you answer no implicitly to the first question.
so it's not wrong if you didn't write anything.
You should have said just no, but but I can tell from the other answers that you're implying, that's a no. Okay, which is fine. Okay, that's okay. I'm only picking when it comes to the mechanism of the trace, but I'm not so picky when it comes to, you actually have to specify no, if you say nope, NOP, I'm not going to take points off either. Or if you say I don't think so, I'm not going to take points off. All right, so I equals 6 right after line 10 executes. We have only one more to do. There are no global variables in this case, so just say no global variables. And that's the end of question number 3. All right, down to the last one. Question number 4. Question number 4 is kind of lengthy, but it's actually not too hard. It doesn't have a lot of tricks as far as parameters and stuff like that goes. It has to do with, arrays and, loops, stuff like that, for the most part. So we'll just go ahead and duplicate the algorithm here. Define sub S3, by ref X, by ref Y, local T, T gets X, X gets Y, Y gets T, and define sub. What would be the proper name of subroutine S3? If you are to name the subroutine based on what it does, what would be a good name for that? Switch, swap, exchange. Local A is an array of 3 integers. I gets 0. I is less than bar A, bar do. A bracket I gets I minus 3. I gets minus 1. While I get 0 again. I is less than bar A, bar minus 1. Equal S3. A bracket I specifies X. A bracket I plus 1 specifies Y. I gets I plus 1. While and on sub equal main. Okay, so let's fix all the indentations. Okay. This one is long. The algorithm itself is kind of long, but in terms of the concepts, it's not too bad. Let's save it first. We got 5 minutes. We'll do it. All right. This one is really just a lot of bookkeeping, and since I did not ask you to turn in the trace, once you understand what S3 is doing, you can just go ahead and do it without tracing all the allocation and deallocation, except for counting columns is concerned. All right, so let's go ahead and get started. We do have conditions. We have line number. Do we have any global variables in this case? Everything is not global because they're all accounted for by local, by ref, and by local in this case. By ref, there's nothing by value in this case. Okay, so we have no global variables. Line number is just free. There's nothing to say. On line 23, we are invoking main. Return line number is post. That's easy. And then we have two local variables. The local variable I is a simple local variable, so it only takes up one column. What about the other one? What about A? It takes up 3 individual columns because we have 3 elements within the array, and each one has to take up 1 column. Now, if anyone allocates only 1 column for A, those people will run into big problems when we have to invoke S3 for the swap operation to occur, because then you'll be passing the same column to the same parameter again, and no real swapping will actually be done. Okay, so we will go into the subroutine. Oh, I forgot one thing. All of these are supposed to be question marks too. But since I did not ask you to turn it into trace, there's no points deducted if you forget about that. Starting in the subroutine on line 12, I is 0 here. On line 13, I is less than bar A bar is true. We go to line 14. This gets 0 because 0 times 3 is 0. We store that into A bracket 0, which is column E. We go to line 15. I gets bumped up by 1. We go back to line 13. I is still less than bar A bar. We go to line 14. This one gets 3. Go to line 15. This bumps up by 1. Go back to line 13. This condition is still true. We go to line 14. This becomes 2 times 3, which is 6. And then we go to line 15 again. This is bumped up by 1. Go back to line 13. So now this is finally false. Okay. Then we go to line 17. Line 17 resets I to 0. And we go to line 18. I is less than bar A bar is true. Then we have to
bar minus 1.
oh, minus 1, that's right. Then we go to line 19 because the condition is true. We have to invoke S3. I'll do it only once, because all the other invocations are pretty much the same. We need return line number, parameter X, parameter Y, and T. We have traced the subwap subroutines several times already, so this really should not come as a big surprise. The return line number is line 20 because the invocation is on line 19. We use A bracket I to specify parameter X. A bracket I is living in column E, so parameter X becomes also known as column E. And we use A bracket I plus 1 to specify parameter Y, and parameter I plus 1, I is 0, so it's referring to column F, so Y becomes an alias of column F. T is a local variable, starts with an unknown value. And let's see, can we see all the columns at the same time? Almost.
Resize the line number.
Yeah, I can. Yep, there you go. Good idea. And we're still a little bit short, so we'll just change the zoom here. There we go. All right, so now we're into the subroutine. I'll just go through the subroutine once because the second time is going to be the same thing. T gets X. So T will get the value of column E. Column E has a value of 0. On line 6, X gets the value of Y. X is also known as column E, so column E is going to get the value of Y. Y is also known as column F. Column F has a value of 3. Then we go to line 7. Y gets the value of T. Y specifies column F, and T has a value of 0. So basically, it's just exchanging the values of the two parameters. Line 8 is the end of the subroutine. We remind ourselves that we have to go to line 20, and then we can deallocate all 4 columns. So I'm not going to trace the entire thing. I just want to give you the answer to this. All right. So to give you the answer, okay, this is line 20. We bump I up by 1, so that becomes 1. We go back to line 18. I is less than I bar minus 1 is true. We go to line 19. So I'll just go ahead and give you the net effect of the subroutine call. It's going to swap, A bracket 1 with A bracket 2. So this will end up with a value of 6, and this will end up with a value of 0. And then we go to line 20, we bump I up by 1, becomes 2. We go back to line 18. This becomes false eventually. And then we get to line 21. So by the time we get to line 21, we don't trace line 21, do we? We trace line 22. This is all that you need to trace because everything else is really just bookkeeping. So by the time we get to here, we can answer the questions. There are no problems with the algorithm. And not counting the columns for comments, line number, and global variables. We allocated column C all the way up to column K. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 columns, up to 9 columns. Not counting blah, blah, blah. And then question number 5 is the tricky one. It asks you, what is A bracket 0 and A bracket 2 right before line 22 executes. So this is line 22. Right before line 22, we look up A bracket 0. It has a value of 3 after all the updates. And then A bracket 2 has a value of 0 after all the updates. So A bracket 0 equals 3. And A bracket 2 ends up with a value of 0. Are there any global variables? No global variables. And that's the end of question number 4. Any questions about number 4? No questions? All right.